Hello everyone, welcome to Math World. This video is to discuss Cambridge International AS and A-Level Mathematics Paper 6, which is the Probability and Statistics 1 for October-November 2018, and the code is 9709/61. So let's move on to question number 1. Now for question number 1, 9 people are to be divided into a group of 4, a group of 3, and a group of 2. In how many different ways can this be done? Okay, so basically very simple. So from 4, you need to divide into from 9, you split it into 4, 3, and 2, 3 groups. So basically, initially, there will be 9, then you have to choose any 4, okay, then times. Now, after you have chosen 4, that means you're left 5, right? So this one done. So from 5, you need to choose 3. So 5, choose 3, and followed by 2, choose 2. If not, you just leave it up to you. Alright, then here you will be getting 126 times 10 times 1, and this is going to be 1260. Or another method is you can just write 9C4 times 5C3. Then you will be getting the same answer because you just left another 2. So if you do not choose, they will be in a group as well. Okay, so for question number 2, the random variable x has the probability distribution as shown in the following table, where p is a constant. Now find the value of p. We know that total probabilities is 1. Therefore, just add up all the probabilities and equate to 1. Therefore, I will be getting p plus 2p, 2p plus 2p plus 0.1, that is 1. So for the left hand side, you will be getting 6p plus 0.1 equals to 1. That means 6p is 0.9. So your p is 0.9 divided by 6. That is 0.15. Now part 2, given E is expected value equals 1.15, calculate or find variance x. So for variance x, we need to calculate EX squared first. EX squared is basically summation of x squared times the probabilities. Right, so go back to the table. You square the x and multiply with the probability. So which means I will be getting minus 1 squared times 0.15. Plus 0 squared, so the whole term is 0. Then plus, the next is 1 squared 2p. So 1 squared times 2p means 2 times 0.15. Plus 2 times 2p. So 2 squared times 2 times 0.15. Lastly, 4 squared times 0.1. Then from here, you will be getting 0.15 plus 0.3 plus 1.2 plus 1.6. That is going to be 3.25. Then now the variance x is EX squared, expected x squared, minus square of expected x. That is going to be 3.25 minus square of 1.15. Then at last, you will be getting 1.9275. And now I round up to 3 significant figures, that is 1.93. Okay, done for the variance x. Question number 3. In an orchestra, there are 11 violinists, 5 cellists, and 4 double bass players. A small group of 6 musicians is to be selected from this 20. Now, first part, how many different selections of 6 musicians can be made if there must be at least 4 violinists, at least 1 cellist, and no more than 1 double bass player. Okay, so I will draw a table. So there are 11 violinists, 5 cellists, C, and then 4 double bass players. Okay, or B. B means double bass players. Now you need to choose 6. You need to meet this requirement as well, minimum 4, right? So here, at least 4. After that, probably I just write at least 4. And then at least 1 C, not more than 1. Not more than 1 means less equals to 1 B. Okay, so now we need to get 6. So at least 4 means probably 4, 1, 1, because not more than 1, right? Or probably I would say instead of choosing 1B, I do not choose, right? Because not more than 1, it can be 0. Then if here's 0, it will be 2 and 4. Or probably I choose 5, 1, 0. So these are the number of selections. It could be 411 or 420 or 510. So now my working is number of selections. So for the first group or first combination, I need to choose 4 from 11. Therefore, the working is 11C4. Followed by means times 5 choose 1. Followed by 4 choose 1. This is for first case. Or is plus. Now to choose 4 from 11, again it is 11C4. Followed by choose 2 from 5. So 5C2. The 0 no need to write because you do not choose any B. Okay, or choose 5 from 11, so 11C5, followed by choose 1 from the 5C, so 5C1. Then from here, you will be getting 6600 plus 3300 plus 2310. Then at last, you will be getting 12210. So that will be the number of selections. Now, the small group that is selected contains 4 violinists, 1 cellist, and 1 double bass player that sit in a line to perform a concert. Now, how many different arrangements are there of these 6 musicians if the violinists must sit together? Okay, so for this case, we need to arrange. There are 4 violinists, 1 C, and 1 double bass player. It's mentioned that all the violinists must sit together. That's why I group this as 1. Okay, so if I group this as 1 means that now basically you have to arrange 1, 2, 3. Right? You have to arrange 3 of them. So now my arrangements will be number of arrangements will be 3 factorial. Okay, and then multiply with arranging the 4 violinists. So times 4 factorial. Then you will be getting the answer of 144. Right? So done for this question. Now here for question number 4a, it is given that x is normally distributed with mean 31.4 and variance 3.6. Find the probability that a randomly chosen x is less than 29.4. So now x is n 31.4, then the variance 3.6, because our formula is x is normally distributed, mean mu, variance sigma squared. So when you need to calculate the probability, you need to standardize the variable. So the z is x minus mu over sigma. Okay, so then from here, I will say px less than 29.4. And then you standardize it. You can say this is z or z. So 29.4 minus 31.4 over the square root of the 3.6. Because this is sigma and you are given variance, standard deviation in the distribution. Then from here, I will be getting p z or z less than negative 1.054. Alright, so now sketch a graph, bell-shaped curve for normal graph. Middle is 0. So negative 1.054 is on the left side, and since it is less than means the region towards the left side. So this region is not available in the table, therefore you have to flip it under or in the line 0 because it is symmetrical at 0, and it becomes the region on the right side. So to get the region on the right side is basically 1 minus the previous region. So that is 1 minus P Z or Z less than 1.054. Okay, then from here you can just read the probability from the normal table in the formula list. You will be getting 0.548,540. So when you minus, that is 0.146, which is 3 significant figures. Now part B. The lengths of fish of a particular species are modeled by a normal distribution. A scientist measured the length of 400 randomly chosen fish of this species. He finds that 42 fish are less than 12 centimeters long and 52 are more than 19 centimeters long. Find estimates for the mean and standard deviation for the length of the fish of this species. Okay, so now basically the mean and variances are not given, so I will just write mu and sigma square first. It's mentioned that out of 400, you find that 42 are less than 12 centimeters length, less than 12 centimeters long. That means I can convert it into probability. So x is less than 12 centimeters long. That is 42 out of 400. Okay, so when you divide, that becomes the probability. So that means now here you are getting px less than 12 equals to 0.105. And again, since this is normally distributed, I will standardize it. So it becomes 12 minus mu over sigma, which is 0.105. Okay, now from here I need to draw the graph. So my graph is bell-shaped curve. Now it is less than a value, but the probability is 0.105. So if let's say less than the probability of z less than 0, this is 0.5, right? But then this probability is smaller than 0.5. That means this line 12 minus mu over sigma should be on the left side, so that it has less region. Okay, the area is less. The probability is same as the area under the curve. So here I will write 0.105. And the line value is 12 minus mu over sigma. Then now here, obviously the value is not available, therefore you flip or you reflect it in the line 0. And when I reflect, the region is 0.105 and the value of the line becomes negative of 12 minus mu over sigma. Okay, then from here I will say PZ less than. This value will be this much. Right? Or probably I will write more than first. Then when we need to count, then we convert to less than. More than negative of 12 minus mu over sigma equals to 0.105. But the region more than, the more than region is not available in the normal table. Therefore, I have to consider less than. So which means I draw this line. Okay, here less than. The probability will be 1 minus 0.105. That is 0.895. So here I will write P, Z or Z less than negative 12 minus mu over sigma is basically 0.895. This is counted by 1 minus 0.105. Then from here, I will refer to the table to get the critical value. So from table, probability of Z or Z less than 1.253, that is 0.895. Then now I will just compare these two. Okay, or probably I will say that these two are equal. So which means negative of 12 minus mu over sigma is 1.253. Then I will be getting first equation. Move the sigma and the minus to the other side. So you will be getting 12 minus mu equals to negative 1.253 sigma. This is my first equation. Okay, so I have to repeat all these steps for the second value. 58 out of 400, the length is greater than 19 because it's more than. So from here I will write px greater than 19 and the probability is 58 over 400. Therefore, px greater than 19, this is 0.145. And now again, you standardize it. So p, z, or z more than 19 minus mu over sigma. That is 0.145. Then from here, I will sketch a graph. So when you sketch a graph, now again, when you take this value greater than this value, that is probability of 0.5. So then now the probability is less than 0.5. That means my line is basically on the right side. This is only 0.145. And the line is with value of 19 minus mu over sigma. Okay, so from here I will write the probability of more than is not available in the table. So I will write less than 19 minus mu over sigma. That is 1 minus the probability. So when you minus 0.145 from 1, that is going to be 0.855. And then now this region, basically this region is available in the table, the normal table. So what to do is you just write from table PZ less than 1.058 is 0.855. Okay, so same method as just now, or same steps as just now. The next step is going to be just equate these two values. So I will write 19 minus mu over sigma equals to 1.058. Hence, my second equation, 19 minus mu equals to 1.058 sigma. Okay, so now I need to solve these two simultaneous equations. Since on the left side, I get both minus mu. Therefore, I can just use subtraction of the equations to simplify the mu. Okay, so I will use second minus first equation. So you will be getting second minus first equation, that is going to be 17 minus 12, that is 7. Sorry, 19 minus 12 is 7 on the left side. 1.058 sigma minus 1.253 sigma, that becomes plus. Then you will be getting 2.311 sigma. Hence your sigma is 7 over 2.311 and you will be getting 3.02899. And now I give more decimal places because I need to use this for the next calculation of the mu. And then as my final answer, I round up to 3 significant figures. That is 3.03. Okay, so now to find the mu, you can substitute into first or second equation. I will refer to the first equation. So now move the minus mu to right side and move this term to the left side. That means my mu is going to be 12 plus 1.253 sigma. I will use the more accurate value, right? Then you will be getting 15.795 and now round up to be 15.8. So that's all for the solution of this question. For question number 5, at the non-land business college, all students sit an accountancy examination at the end of their first year of study. On average, 80% of students pass this exam. First part, a random sample of 9 students who will take this exam is chosen. Find the probability that at most 6 will pass the exam. So obviously this is binomial distribution, right? So x is binomial, the n is 9, the passing rate is 0.8. That means now your x is number of students who pass the exam. So the p is 0.8, that means your q is 1 minus 0.8, that is 0.2. So the Q is those who fail. That means the failing rate. So then from here, at most 6. At most 6 means maximum 6. So maximum 6 is less equal to x. less equals to 6. Now when you refer to the binomial formula, okay, this is the formula. Your x value actually starting from 0 until n, when it is x is binomial distributed with n and p. So now your n is 9, and less equals to 6 means supposedly you calculate px equals to 0 plus until px equals to 6, but it is a lot of calculations. Therefore, I will use complementation rule, that is 1 minus the rest. Okay, so the rest will be 7, 8, and 9. So my calculation is 1 minus px equals to 7 plus px equals to 8 plus px equals to 9. So this is 1 minus, okay, so now 9c7, the p is 0.8 power 7, and then the q is 0.2 power 2. Because out of 9, 7 successors, it will be 2 failures. Plus 9c8, 8 successors out of 9, that is 0.8 power 8, 0.2 power 1. Lastly, px equals to 9, means all 9 successors. So I will calculate each of the value and give more decimal places. Then here you will be getting 0.2618025. And now I round up to 3 significant figures, that is going to be 0.262. That is the first part of question 5. Okay, second part. A random sample of 200 students who will take this exam is chosen. Use a suitable approximate distribution to find the probability that more than 166 of them will pass the examination. So now your x becomes binomial, n becomes 200, and we are counting the probability of passing the exam. So the same probability applies here, 0.8. But then since your n is more than 30, therefore we need to approximate to normal. So the mean of the binomial is NP, that is 200 times 0.8. Then I will get 160, which is greater than 5. Okay, and the NPQ, that is the variance of the binomial distribution, then you will be getting 32. So from here, I will say my x initially binomial distributed with mean 200, with n 200 and p is 0.8. Now it will be approximate to w, normally distributed. The mean is 160, variance is 32. Okay, now calculate probability of more than 166. So px more than 166, you change to pw more than. Now from discrete, binomial is discrete, change to normal. Normal is continuous. So we need to carry out the continuity correction factor. So which means you mark this value more than 166. So I know that the values will be 167, 168. Okay, and now we are allowed to plus minus 0.5 from 166. So when I minus 0.5 from 166, that is 165.5. If I plus, it will be 166.5. And since here is more than, that means I have to choose greater than 166.5 to include the two ticks. So greater than 166.5. Then now I need to standardize it. So I have to change the W into Z or Z. Okay, so here I will write P, Z or Z more than 166.5 minus mean is 160 over square root of 32. Then from here, you will be getting P, Z or Z more than 1.149. And now I sketch a graph. So here is 0, this is 1.149. Greater than means the region out on the right side. So this probability is going to be 1 minus the region less than that. So this is going to be 1 minus B, Z or Z less than 1.149. and that probably you can get it from table. That is going to be 0.8747, and now here I will be getting value of 0.1253, and at last three significant figures, that is 0.125. Okay, now justify the use of your approximate distribution in parts 2. So basically, the n, you can say n or NP, just calculate the NP. NP is 200 times 0.5, which is 160, that is greater than 5, and also NQ. Okay, we are checking these two values basically. So the NQ is 200 times 0.2, that is 40, is greater than 5. So these two are the justification for normal approximation to binomial distribution. Okay, number 6, the daily rainfall X millimeters in a certain village is recorded in 250 consecutive days. The results are summarized in the following cumulative frequency table. Okay, so now on the grid, draw a cumulative frequency graph to illustrate the data. So look at the X values. This is the horizontal axis. This is the vertical axis. This is the horizontal. So horizontal axis, we have to include 20 up to 100, right? So now I check first. 20, 40, 60, 80, 100. Okay, so right, so this is 0. Then that is the X rainfall. So here I will just write rainfall in millimeters. Then the cumulative frequency is up to 250. So if 250, the easiest way is 50 for each. So here 50, 50 for 10 squares. So 150. Then here is 200. Then this is 250. So I will label this as cumulative frequency. Okay, so now mark all the points. Less equals to 20, it will be 52. So now remember here 50 units for 10 squares, each unit is 5. Right, 52 means it will be somewhere here. 52. Then less equals to 30, it will be 94. 94 means here is 90. Right? Then less equals to 40 is 142. 142. This is 140. Less equals to 50, 172. 172. Okay, 15, 16, 17. So probably is here. Less equals to 70, 222. 70 is here. 222, 220, 210, 220. So it will be here. And then less equals to 100, 250. 250, 100. Okay, so now sketch a graph. Draw the points. Start from 0. Okay, so draw the smooth curve. Right. Okay, now on the 100 of the days, the rainfall was K millimeters or more. Use your graph to estimate the value of K. So 100 of the days. So days is the cumulative frequencies, right? So now you just draw 100, draw the dotted line. So then from here, I will get this value. So here I get for, okay, let me check. 100 of the days, the rainfall was kmm or more. Okay, so let me check the graph first. 94, okay, now 94, 30. Right, let me check. Here is 94, 30. On 100 of the days. Okay, wait. This, if I draw 100 over here, this value is less, right? This is more. That means I shouldn't draw 100. It should be the top 100. Okay, mistake over here. This is the bottom 100, which means on 100 of the days, it will be K or less, right? So now K or more 100 of the days means that you have to consider 100 from 250. So that means that is 150, right? Because of the more there. So then I will get this graph. Okay, so be careful with this. That means now here, basically if you refer to the horizontal axis, 20 units for 10 squares, each unit is 2. Okay, that means now my value here is basically 42. Okay, so my K is 42. Right? So probably you can just write 250 minus 100. That is 150. That is the position of the data. So K equals to 42. Right? Okay, now part 3, calculate estimates of mean and standard deviation for the daily rainfall in this village. Okay, so now I have to construct the table because you were given the cumulative frequencies and also the rainfall. All these rainfalls are the upper class boundaries. So I will say that from 0 to 20, less equals to 20 means from 0 to 20, right, up to 20. So now here I will write my x is basically 0 to 20. Then 20 to, the next is 20 to 30. Okay, because if I write in this form, I scared that no enough space. So I will just write in the other way. That is 0 to 20, 20 to 30, okay, 30 to 40, because the next one is 40. Then after that, 50, 70, 100. So 50, 70, 100. Then the next is chromatic frequency. The first one is 52. So the frequency will be 52. Okay, the second class, this chromatic frequency is 94. So it means that the frequency itself is 94 minus 52, right? Then you'll be getting 42. So here, I will get 42. And the third class, you minus as well. So 142 minus 94, that is 48. So you just keep minusing the previous cumulative frequency. That will be the individual frequency. So here I will be getting 48, and then 30, 50, and 28. So now I need to find the midpoints. So the midpoints is basically get the average of the class limits. All these are the class limits. So 0 plus 20 divided by 2, that is 10. The next one is 25, followed by 35, 45, 60, and 85. So now my mean is basically summation Fm over summation F. This is X bar as well. So probably I write this because I will use this value in the next calculation, which is a standard deviation. Then from here, you will be getting Fm, so times, right? 52 times 10, because of the summation, you plus. So 42 times 25 plus 48 times 35 plus 30 times 45 plus 50 times 60 plus 28 times the 85 over the total F is basically, you can get it from the cumulative frequency, that is 250. Okay, so I will just write over 250. Then here is going to be 9980 over 250. So the mean is 39.92, and I round up to be 39.9. Okay, this is the mean. But then the question asking for standard deviation as well. So the standard deviation is basically square root of the variance. So the variance calculation is summation Fm squared over summation F minus mean squared that we have just found. That means this is going to be square root of Fm squared, means now you square the m. So I square all the second term inside the bracket. I mean the terms inside the bracket. So I will write 52 times 10 squared plus, refer back to this step, just square all the terms inside the bracket. Okay, then over summation F is 250 minus the mean squared, so 39.92 squared. That's why you need to give more decimal places in the mean calculation. Okay, so from here you will be getting 5,333,000 over 250 minus 39.92 square root. So you will be getting the value of 23.229, and now round up to 3 significant figures, that is going to be 23.2. Okay, that is the standard deviation for this question. Now for question 7, in a group of students, the numbers of boys and girls studying art, music, and drama are given in the following table. Each of these 160 students is studying exactly one of these subjects. Now, first part, find the probability that a randomly chosen student is studying music. Okay, so music will be this total. So the probability equals to 40 plus 12 over the total 160. So this is going to be 52 over 160. Then you will get 13 over 40. Now part 2, determine whether the events a randomly chosen student is a boy and a randomly chosen student is studying music are independent, justifying your answer. Okay, so probability of a boy. So boy is basically total of these three values. So 24 plus 40 plus 32 over 160. So that is going to be 96 over 160 and simplify into 3 over 5. Now the probability of studying music. So music, we already found the previous part. That is 13 over 40. Okay, and now I need to calculate the intersection probability between boy and music. So that is intersection. So according to the table, boy and music is only 40. Okay, so 40 out of 160. So this is 1 over 4. So now I want to check whether they are independent or not. Means that if they're independent, okay, so the probability, the products of individual probability will be same as the probability of the intersection. So which means now probability of boy times probability of music, that is 3 over 5 times 13 over 40. Then this is going to be 29 over 200, which is not equals to the intersection probability. So when they are not equal, that means the events are not independent. Okay, so probably you can just write not independent because they are not equal. Okay, now part 3. Find the probability that a randomly chosen student is not studying drama given that the student is a girl. So given that means conditional probability. Right? So now it's not drama given that it's a girl. So the probability, conditional probability formula is P A slash B equals to P A intersects B over PB. So then this is defined as P not drama and it is a girl over P the probability of a girl. Okay, not drama and a girl. So go back to the table. Not drama and a girl, that means now, okay, look at here. So not drama means cannot this, and it is a girl. Alright, that means you will have 15 plus 25. That will be the not drama and girl. So I will get 15 plus 12. So 15 plus 12 over 250, or over 160, sorry, total 160, divided by P girl, probability of getting a girl. So a girl is summation of these three. So I get 15 plus 12 plus the last one is 37 over 160. So basically the 160 no need to write because it will be cancelled off. Okay, so from here I will be getting 27 over 64. Okay, now last part, or part 4. 3 students are chosen as random. Find the probability that exactly 1 is studying music and exactly 2 are boys. Okay, so now 1 music, okay, probably I let M be music and B be boys. So I will get 1M and 2B. Okay, so which means now here I will say 3 students. So alright, so what I can say here is exactly 1 studying music. Okay, 1 music. So 1 music and 2 boys. And 2 boys. Okay, times. Okay, wait. 1 music and 2 boys. That means it could be, okay, boy and music, right? This is the first student. Boy and music. Exactly 1 music. And the next one is boy and not music, because we need 2 boys. And the third one will be girl and not music, right? That's why exactly 1 music, 1 M, and exactly 2 boys. So now or is plus. Probably I would say the girl and music, and now the music is already taken, one of them, but it is girl. That means the other 2 boys will not be music. Okay, so these are the 2 cases that satisfy the condition. 3 students are chosen. So now, when you consider this, okay, boy and music, let's check the table. Boys and music, we already solved. 40 over 160. Alright, so I will write 40 over 160, it will be easier. So 40 over 160 multiply with boy and not music. So if boy and not music, since you have chosen 1 student, that means you still have 159 students. Not music, it will be, okay, I need boy first. You look at boy. Not music means that these 2, right? So 24 plus 32, that is 56. So I will get 56. Alright, and then followed by girl and not music. So refer to the table. Girl and not music now becomes these 2, either arts or drama. Therefore, when I add these 2 together, 37 plus 15, that is going to be 52. So here I write 52 over 158 because getting lesser. And now, okay, I need to arrange these 3, because if I write in this case means that first boy with music, second boy without music, third is girl without music. So it can be in any arrangements, because we need to choose 3 students. So it can be the first girl without music. So you have to arrange these 3. So therefore it is 3 factorial. Okay, plus now girl with music. Girl with music, it will be girl with music 12. So initially it is 160 students. Okay, initially it was 162 students. Then multiplied with boy and not music. So boy and not music, basically we have counted just now. So total here is 56 over 159 times boy and not music. So boys and not music, that will be 55 over 158. And now here, okay, just now we times 3 factorial, you look at here, because these 3 are totally different. B and M, B and not M, G and not M. That's why 3 different, uh, 3 different, 3 different of them. Okay, so but then when you refer to the next case, these 2 are same. Both boys without music, right? So when I consider the arrangements, it will be 3 factorial over 2 factorial, because the B and not M are repeating for 2 times. So with this calculation, you will be getting 728 over 4187. Then you plus with the next one is 231 over 3. Okay, let me count this first. 8374. Okay, so when you calculate this total, that is going to be 1687 over 8374, and at last you will be getting 0.201. Okay, so this is the solution of this question. Alright, so be careful for the arrangements over here, times 3 factorial and 3 factorial over 2 factorial. Alright, so we have come to the end of the paper and also comes to the end of the video. Thanks for watching. If you enjoy watching my video, please subscribe to the channel and share this channel with your friends. And also stay tuned for more upcoming videos. Thank you everyone. Bye.